Okay, 17 of the section 3.4. Sketch a graph of each function to be sure the level 3 point on the graph. Okay, this is the identity function. This is identity function. Identity function x and y, and the point is 0, 0, 1, 1 here, 1, 1, and here negative 1, negative 1. Negative 1, comma, negative 1. That's the three typical points for the identity function. The name is identity function. 0, 0, 1, 1, and negative 1, negative 1. It's a typical odd function. Odd function. Okay, 19. 19 is a cubic function. F of x is equal x to the cubic power. Let's do in the graph and three typical points. X, y, 0, 0 again, because 0 to the cubic power is 0, 1, 1, 1, 1, and negative 1, negative 1. Negative 1, negative 1 is here. Negative 1, comma, negative 1. But the problem is it's not linear, it's quadratic, and quadratic look like that. Okay. 21. 21 is a reciprocal function. Reciprocal function. Let's see reciprocal function. 21. 21 is xy. Is 1 point is 1, 1, because reciprocal 1 is 1, 1, 1. And another is negative 1, negative 1, because reciprocal negative 1 is negative 1. Negative 1, comma, negative 1. But it's look like that. Okay, reciprocal function. Reciprocal function have two asymptotes. Have the horizontal asymptote here. Horizontal asymptote. Because the equation is y equals 0. And the vertical asymptote here is y x equals 0, no y. Is on the y-axis, the equation of the y-axis x equals 0. So we have, okay, they want three typical points. 1, 1, negative 1, negative 1, and another maybe is 2.5. So another point here is 2.5 or 1.5, 2. Approximately that. This point is 1.5, 2, because it's reciprocal. Flip it. Super. Now 23. 23 is cubic root function. Cubic root function is like that. xy. Cubic root 0 is 0. So the origin 0, 0 belongs to this. 1, 1, 1, and negative 1, negative 1. Okay, this point is negative 1 comma negative 1 and 1 comma 1, because the square root 1 is cubic root 1 is 1 and cubic root negative 1 is negative 1. And one more point, cubic root 8 is 2. Entonces 2, 3, 4, 5, 6, 7, 8. 8 comma 2. That's another point. So this look like that. And this is typical odd function again. This is odd and this is also odd function. Okay, very well. We have to, this is a point a comma 2, this is a point 1 comma 1, and this is negative 1 comma negative 1. 3 points. Okay, sketch the graph of this piecewise function and compute 3 points. Okay, let's do it in the graph. The graph rectangular coordinate system. This is x and this is y. Okay, the first piece is the parabola. The parabola is 0, 0, negative 1, 1, and 1, 1. So the parabola look like that. This. Okay, so this is the parabola. Of course, symmetric with respect to x. This is the x squared function, okay, it's the first piece. The second piece is just 2. 2 is here. 2. Horizontal line. And the last piece is 2x plus 1, because the line, the y-intercept is 1 and the slope is 2, therefore it's 1 and 2 rise here. This is the line que corresponde with the equation 2x plus 1. Okay, now the transition point is in 0. 0 is a point when they change the piece, and 0 is here. This is a line that represents x equals 0. Before 0, negative value, is valid this piece. Therefore, this piece is valid in the negative part. In this moment, we have a circle here, but this circle is empty. Why? Because it's not equal here. Only included this part. After, for the x equals 0, the low is 2. 2 is a horizontal line, so therefore we have here a full circle, because it's equal. Now we navigate until, okay, after that for x greater than 0, so a positive value is valid this expression. So for a positive value is valid this expression. We have again here a circle empty here, 2 empty and 1 full here. Okay. And we navigate for the line, okay, it's this part. Okay, and this continues forever. The rest was only auxiliary. This is nothing, this is nothing, and this is nothing. Our piecewise function is only the blue curve. Para to evaluate, suppose evaluate f, evaluate a negative 2. Negative 2 belong to this interval because it's negative value. So we use this law. This is equivalent. negative 2 squared, que es 4. F evaluate specifically at 0. Well, at 0 is this condition, so the answer is just 2. And F evaluate at 2. F evaluate at 2 is positive, is belong to this condition. Now it's valid this expression, so it's 2 times 2 plus 1 is 2 times 2 is 4, plus 1 is 5. Okay, and this is the answer for the 25. Okay, 27 is another piecewise function, but in this case we have two pieces. The first piece represents the line. I draw the line. The line is 2x minus 4. So the y in z is negative 4, and the slope is 2, so there's 1 here and 1 and 2 here. Now you connecting this point with the line, 2x minus 4. And the other is a cubic, but we have some translation, negative 2 down. Entonces is for 0 is negative 2, que es this point. At this point is a point 0, negative 2. And from this point I move a 1, 1 here and 1, 1 here. And approximately I plot the graph. Ahora the transition are, let's see, is negative 1 is one transition. Another transition is 2, positive 2, 1, 2 here, positive 2 is here. It's a coincidence, que es de x-intercept. And 3 is here. So this is negative 1, this is positive 2, and this is positive 3. X equal 3. Okay, entonces, for example, negative 1. Negative 1, navigate for the line, que is here. We have circle full here, and 2, we have circle full here. Okay, and in between, we have this graph. This is valid, and we have 2 full here and full here. Now, okay, this curve continues, I suppose, like that. Okay, so now, in this case, we continue with the magenta color. And between 2 and 3, we have here empty. This is empty circle because it's not equal here, and this is full. And 3 is full circle. And the graph look like that. Okay. Now let's see. For example, day 1, can you evaluate at 0? So we are doing 27. F evaluate at 0. F evaluate at 0 is inside this interval. You plug in 0 here. 2 times 0 minus 4 2 times 0 minus 4 is negative 4. F evaluate at 1. 1 is inside this interval also. Is 2 times 1 minus 4. Is 2 minus 4 is negative 2. And F evaluate at 2. This is 2 times 2. We're using 2, even 2, we're using this expression because it's equal. Minus 4 is 4 minus 4 is 0. And finally, F evaluate at 3. Oh yes, we're using this because 3 is here. So it's 3 to the cubic power minus 2. It's 27 minus 2 is 25. Okay. This is the value, okay, day 1, and this is the graph. So this point would be 3,25.